Hello everyone. Now today we have another session. We're talking about 1.4 in your chapter. Was also a little bit need more detail. So after this one we have 1.5, which is not more complicated. It's easy. I think you can deal with it. As easy as much that you can. Okay, dear. So 21, 30, that's it. So in this section we have rational expressions. Before we got one point in 1.3 where we have algebraic expression. Now we have a rational. When I say rational, means that we have polynomial over polynomial. When I say polynomial, I mean x squared plus 5x minus 2. This is the trinomial, as you know, it's a polynomial over what? Over x minus 1, for example. Now we have this one. The objective of this session is what? Is to find the common factor between them. So we have two things here. We are dealing with the domain, so forget about the domain. Any questions that deal with the domain, forget about it, because really this one is not included for you. I need more mathematics background. That's good for calculus 1. So that's why for engineering departments in general. So that's why we say forget about domain, because here we are dealing with the about simplifying rational expression, multiplying and dividing rational expression, adding and subtracting between them. So that's all that we need here, really. That's why I say forget about the domain. So now for this one, as usual, you know how we deal with the trinomial. For example, if you have x squared minus 5x plus 6. Now for something like that, before we say because I have a trinomial, I'll change it to two binomial, and with the two parentheses. So I say x. Now addition positive negative, I will get negative by positive negative. So I have 6. So 6 2 by 3 or 1 by 6. As you know, it's better to put 2 by 3 because the subtraction between them should be 5. So 2 3 is 5. So that's why I put 2 and 3. That's all. In that case, this is in the 1.3. In that case here, we have something like that. X to power 2, x to power 2 minus 5x plus 6. I will told you to simplify. You know, you can change the denominator, denominator, and the numerator, so x minus 2 remains. And I will try to do my best here as I did it here. So x minus 2, x plus 3, minus 3, which we did before. So in that case, we will cancel this one, and I say I will get the 1 over x minus 3. In that case, this means that we simplified our rational expression. Okay. So in page, there's nothing important here. In page 30, we start our first steps that I need. Simplify the following rational. What do you mean? AC, BC is equal to AC means that we will cancel the common as I did it before here. We will cancel the common in the denominator, Jericher, and numerator, Sericher. That's all that we need. So in that case, for example, we have what? We have x squared minus 1, which is example 2 in page 30. Okay, example 2 in page 30. So it say that x squared minus 1 over x squared plus x minus 2. I will apply all tricks, all formulas in the 1.3 here. How? I notice the difference between two squares, and this is trinomial, so I will change it to something like that. X positive negative. I have 2 by 1, forgetting 1. So now you can see there's a common in the numerator and denominator, so directly we will canceling them. I say x plus 1 over x plus 2. That's all. Okay, dear? So this is the simplifying the rational expression. I think it's not hard, because in the 1.3, if you understand each steps in the 1.3, so you can do here as a easier part. Also we have what? We have multiplication, so, and division. So how we do multiplication, you know, as I did it before in the before expression, we have a multiplication. We just numerator with the numerator, denominator with the denominator. If there's any common, we will cancel it. Example 3 in page 30. So we have two rational expression that multiplied here. Okay, I have x squared plus 2x minus 3, x squared plus 8x plus 16. Okay, multiply, this is the first fraction, multiply the second fraction with all of them. They are they are expression, and they need more work. So in that case, if you are concentrating on the first part, try to factor them. That's the key. So try to factor them. So I have x maybe here. Now addition, subtraction, 3. So 1, because 3 should be the largest one, because I have a positive here. Now how about denominator? For first part fraction, denominator, so I have x. As I told you, this is a really perfect square, but I don't care. Plus 16, 4. You can also erase them and write square here, but I don't care. As I told you, do in this simple way. Now it's the time to take a 3 as a common in the second numerator. So I have x plus 4 and I have x minus 1. Now it's time to canceling or finding the factors. So here and that one, it remains what? It remains 3x plus 3 in the denominator, x minus plus 4. That's all that we needed, and I think it's easy, because if you deal with that one with the 1.3, you can deal with that one very easy. That's why I say the math is a chain. So take your time to control 1.3. Okay, now again we have division. How we divide? If I have a over b, divide c over d. So how we divide? As I told you before, we have in 1.2, I think. This one we will change that division to multiplication, and we reverse the second part. That's all. And if there's a cancellation, we will do it if there's a common. So for the example 4 in the page 31 in your lecture note, we have x minus 4 over. Now I will do my simplification directly. I say x minus 2, x plus 2. Why? By what I say that? Because this denominator is the difference of squares. I will change the division to the multiplication. Okay, now we will reverse this part. X squared plus 5x plus 6 and x squared minus 3x minus 4. Now time to what? Time for simplify both fraction. Okay, we really already we did the first fraction. We simplify. Now it's time for this one. Now I will change it to xx. So I have x addition 5 3 by 2. Now how about this one? Again x negative positive 4 by 1. Okay, dear. So now you can recognize that we have many things here for what? For simplification. So we cancelled this part, and it remains x minus 1 2 x plus 1. Okay, I think it's easy. As I told you, just control 1.3 1.4 in your pocket till this one. Be sure that this part, addition and subtraction, it depends on the cases. Do you remember 3 cases? Case 1, case 2, and case 3. Which cases? F1 plus F2. So addition and subtraction between what? Between 2 fractions. But here our fraction is what? Our fraction is rational expression. هر وكو كوكرنوي دو كرتوا والله ما شي فرقي كردوا دبعتي الرقم x y معنى. So that's why I say just try to control them. Now how about example 5? Now you have addition and subtraction, you know, case 1, case 2, case 3, and it's more easier if you control the previous cases that I told you. Now example 5, page 31, we have what? We have part A and B. I'll try to solve it quickly for you. We have 3x minus 1 plus what? X over x plus 2. So f1 and f2. F1 and f2. Here's f1, this one f2, and there's addition between them. Now, as I told you, they are the case number 2. Why? Because they are totally different. So in the totally different, we say that we will multiply these together. So I will get common denominator. So here's the common denominator, and we multiply the cross. We put addition in case we have addition, or subtraction in case that we have subtraction. Now the second cross, like that. Okay, that's all. If there's any, if you see there's a you can simplify them, do it. So we multiply, we say 3x plus 6. I multiply this one by here, that one. Now plus x square, x by x, minus x here, over this one, and plus. Please do not try to multiply these one together, because there's a they simplify. They are factor. So why we are complicating this? So I will arrange this one, x2 minus plus will remains 2x plus 6, and I will see if there's a common or not, over what? X minus 1, x plus 2. And I cannot really distinguish this one because they are not complete square, so just leave that as you have. Okay, dear. So now I'm going to 32, page 32 in your lecture note for part B. The same example, part B, on page 32. So the first part, the first fraction was x2 minus 1, and the second was what? Was x plus 1 whole square. Okay, now I will simplify this part. Why? Because as I told you, we need to do it. Why? Because we need a simplification. We should simplify all of them. So x minus 1, x plus 1, difference of squares. So sorry, one here. Now we have two fractions, f1 and f2, which they are totally different, but there's something between them as a common. So this one is the mix between case number 2 and number 3. So be careful, and this is very important how to do it. This one is the difference, so we should multiply by here, right? So x minus 1 plus x minus 1, but square. They are different. Forget about this one, because this is like that. The second denominator here, this is like a here. They are, but with the smallest exponent. So in the case number 3, we say, for example, if I have 2 and 4, we choose the 4. We choose the largest one. So between this one and that one, we have what? We have that. Now, what remains? What I should multiply the first fraction? I should multiply just by x plus 1. So I say 1 by x plus 1. Negative 2 Okay, minus 2. So what remains for here? What we have, what we missed? We missed minus 1. So we multiply x minus 1 to the numerator. Please try to review these all three cases. Otherwise, you cannot understand what did I do really. So now x minus 1, x plus 1 square. Now x plus 1 we multiplied minus 2x minus by minus positive 2 by 1 2. I know I am very quick, but you have a record so you can play it again and again. Okay, reply it again and again. So now I have minus 2 with the 1 and 3. So I got what? I got minus x plus 3. That's all we have. Okay, dear. So this is about page 31 in your lecture note, and he changed it to get the negative here. You can rewrite this one as here. That's it. So there's no difference. Try to solve this example, and this example really was interesting, and there was the one idea here that you can mix it is what is the mixing between C2 and C3. This one with that one we solve it by C3, and this one with that one we solve it by C2, sorry. So you need to practice on this example and review my video, reply it a lot, then you can solve 43 and 45. Now compound fractions is very easy. The example 6 in page 31. Why it's easy? Because you know how to deal with that one. We have what? X over y plus 1 all over 1 minus y over x. So first of all we will fix or deal with the numerator. So you know why, because this is the 1 and this is the case number 2. So this is that we have. How about here? Again we have x minus y, and because you have a multiplication we say the first part will remain and the second will be reversed to what? To x minus 1, and there is nothing to say cancelling or something, just leave it like that. That's all. Okay, dear, that's all that we have. Solution 2, forget about it, there's another way. Try to solve 59 and 61. It's a good example in it for more practicing. Okay, again simplify. Let me see just what we have. This section is not more longer, it's easy. As I told you, 1.3 was the really boring because there's a lot, but you need more practice. So please play 1.3 at least, watched at least twice or 3. Okay, so how we simplify this one, and what's the difference? As I told you, this example, it look like, let me find for you, it look like example number 14 in page 26. Example 14 in page 26. If you don't understand how we did that, how I took the smallest exponent here, really you cannot control or understand in example 8 in page 33. That's why you need more work. So how we solve this? How we solve? Now I will do it here in case you didn't understand. Example 14 in page 26. Now it's time for getting both ID here and there. So example 8 in page 33, as I think, simplify. Just my question in the exam or the quiz, I think simplify. So I have what plus x squared 1 over 2 minus x squared 1 plus x squared minus 1 over 2 and over 1 plus x squared. Now you can see what's the common. So forget about denominator because denominator is simple. So I have 1 plus x squared. Now how about numerator? Between this and that, think about this and that as our example for 14 page 26. So I think these are our common. So what's the trick? The trick should be we took the smallest exponent. So which of them are the smallest exponent? I know this is the smallest, so I'll take it out. Say 1 plus x squared minus 1 over 2. And do you remember that I say put this one itself as that we have here minus and cancel this one because we took it out, just x squared. Do you remember that? That's all that you need. Okay, and the other step what was we took here out, so I say minus here, minus here. If it's a 1 over 2, you say minus 1 over this. Minus 1 over 2, you say minus 1 over 2. We don't care about the sign. So this one is equal to what? In the denominator we have 1. This one that we stay here, it's okay. How about here? Minus by minus will change to what? We'll change it to 1 over 2 minus x squared. And 1 over 2 is equal to what? Is equal to 1. And if there is 1 means that we don't need a bracket. So it remains in the numerator 1 plus x squared minus x squared. So plus and minus will remove. What remains? Just 1. So means that is equal to 1 plus x squared, all of them minus 1 over 2 over 1 plus x squared. Okay, I will repeat this step for you. Say is equal to 1 plus x squared. Okay, now 1 plus x squared, we took this one as a common. It remains, we say 1 plus x squared minus x squared. This one was 1 over 2. Now, because we took this one, I say minus 1 over 2. Okay, and you know, minus will be changed to the plus 1 over 2. Half and half is equal to what? Is equal to 1. Okay, is equal to 1. Now, 1 means that 1 plus x squared. 2 power 1 means what? Means itself. So, and they cancel, so just remains 1, means that just remains that. And this the power is negative, so we'll come to what? To down to the numerator. In 1.1 I told you these are all workable, so you don't need to memorize, you need to practice. So 2a1 over 2 is equal to what? 3 over 2. Why? Because the base are equal, so we add the exponent. So and let me clarify some basic or the common error. Please, we have no such rule that like that. There's no rule like that. Avoid. Okay, there is no rule like that. You cannot divide, or there is no rule to divide to say if you have two, or if you have binomial of the fraction you can divide. No, just we have this. It's a complete square. First by second square. But this one is not equal to that one. Please do not make it as a more complicated. Please do not make it as easy that you think so you are right. No, you are not right. Okay, forget about the solution too. Now and this one is just by rationalizing denominator, and you can just say we will multiply by conjugate owl. So if you have something like that, just multiply by the owl, by the conjugate, and you will get the rational denominator. I think this is not more important, but try to solve 77. Okay, so in there we finished. It's really 33. We finish our section 1.4, and please read these carefully. The common mistakes that the student avoid will do it. Look all these fractions. That's all for you in this section. Have a nice time, and I hope see you in the next week or the next session. And I'm going to finish chapter 1 with the 1.5 and 1.6. The equation and inequality, they are very important. Thank you for watching, and thank you for everything. That's all.